Alright, today we will discuss about neuroglia cells. As we know, there are two kinds of cells are there in nervous system. One is a neuron and another one is a neuroglia. We already studied about neuron. Today we are going to study about the neuroglia. Neuroglia is a special type of connective tissue. It's a special connective tissue which supports the neuron. Support neuron in the sense of both functionally and structurally and the nutritional aspect. Whatever the neurons need, all those are supplied by neuroglia cells even by protecting the neurons from the bacterial viral attacks. Neuroglia cell does not have that capacity to generate impulses by themselves, and they do not carry impulses from one place to another place. Those are the function of neurons. That's why neurons are the excitable cells and neuroglia are non-excitable cells. And they undergo mitotic division. Meanwhile, neurons does not undergo mitotic division. They do not multiply, but neuroglia will multiply and increase their number. The same reason why the neuroglia cells are 10 times more than the neurons. Neuroglia cells are 10 times more than the neurons, and they form the major component in the CNS. Now we will study about the classification of neuroglia cells, right? In classification of neuroglia cells, we will divide in two components. The neuroglia cell present in the CNS and neuroglia cells present in the peripheral nervous system, PNS. Okay. The neuroglia cells in the CNS we will divide into two components, again macroglia and microglia according to their visibility and the sizes. In macroglia we will have three kinds of neuroglial cells. One is the astrocytes, oligodendrocytes and ependymal cells. Schwann cells present as a neuroglia in the peripheral nervous system. Macroglia are ectodermal in origin. Microglia are mesodermal origin. The Schwann cells also, they are the neural crest cells origin, nothing but they are also ectodermal in origin. Now we will discuss about the astrocytes first. These astrocytes are main neuroglial cells of a nervous system. In central nervous system, the astrocytes component is more, and as the name only suggests, astro means star. Okay, they are star-like cells are there. Okay, they are star-like cells and the main supportive neuroglia of central nervous system. In these astrocytes, there are again two varieties are there. The astrocytes of two types are there. One is a protoplasmic, another one is fibrous astrocytes are there. In protoplasmic cells, the processes of the astrocytes are thick and short. They are thick and short. But in the fibrous, they are long and thin. Okay, the long and thin processes are there. In fibrous astrocytes, the processes are long and thin. But in the protoplasmic astrocytes, the processes are short and thick, and which contains a protoplasm, cytoplasm, also called as a protoplasmic. Here the fibrous-like appearance of the processes are there, so called fibrous astrocytes. Now we will come to the discussion about the functions what the astrocytes are going to do. These astrocytes are going to form a blood-brain barrier and restrict large molecular entry, and they allows only the dissolved gaseous exchanges and certain small molecules they are going to allow. So the astrocytes are going to form the maintain the blood-brain barrier. They are going to store the glucose for the neurons in the CNS. They act as major storehouse for the glycogen. The next one is about the macroglia is a oligodendrocytes. Okay. Oligo refers for less in number. Dendrites, their dendrites are less in number, so called as oligodendrocytes. As while studying about the neurons, we study about the Schwann cells there. The Schwann cells are going to form the myelination around the peripheral nervous system, and the oligodendrocytes are going to form the myelination around the central nervous system. These oligodendrocytes are going to present abundantly in the both white and grey matter of a CNS, and they form they present in the form of a clusters and attaches everywhere around the neurons, and majorly more on the axonal part or the extensions part of the neurons. The functions of oligodendrocytes are they are going to form the myelination around the nerve fibers of the CNS. Okay, so for example, this is a one astrocyte and this is a nerve axon. It's going to form the myelin sheath around the one axon. Okay, it forms the myelination around one axon. It not only do one axon, it will do multiple axon myelinations. They can do multiple the one astrocyte, one oligodendrocyte can form the myelination around multiple axons, not only one, multiple. But in the Schwann cell, one Schwann cell will do one axon on one segment. But by the oligodendrocytes, each and every process can do the myelination around the axons. Now third one is about the macroglia is ependymal cells. Ependymal cells present in the CNS and they forms the inner wall cellular layer of the ventricles. In the CNS, ependymal cells, these are the CNS part, the cerebellum, midbrain, pons, medulla oblongata, and the spinal cord, the lateral ventricle, third ventricle, fourth ventricle, and the central canal of a spinal cord. Right? So these ependymal cell present and they form everywhere around the inner surface of the ventricles. Cells are called as ependymal cells, and these cells are generally called as ependymal cells. But we have choroid plexus which synthesizes a CSF inside. I don't go in detail. In some other classes we will discuss about how the choroid plexus are going to form and how CSF is going to secrete. But for the time being, we have a pyometer extension inside. We have pyometer extension inside, and there are these are the choroid plexus of lateral ventricles. Okay, choroid plexus. These are the choroid plexus of lateral ventricle. These are the choroid plexus of third ventricle. These are the choroid plexus of third ventricle. choroid plexus of fourth ventricle. These are the choroid plexus of fourth ventricle. Around this surface of this choroid plexus, there are some ependymal cells present here. Okay, and these ependymal cells will secrete the CSF inside the cavities, lateral ventricles. These type of ependymal cells surrounding this choroid plexus are called as choroid epithelial cells. So there are three variety of ependymal cells are there. One is the ependymal cells generally present everywhere on the surface, inner surface of the ventricles. Some present on the choroid plexus which help in a synthesis of CSF. Another one variety present here in third ventricle and fourth ventricle here. Some ependymal cells are there, and on the floor of fourth ventricle some ependymal cells are there. They are get connected. They will be having long processes. They are getting connected with this hypothalamus. Here the hypothalamus is there. Okay, to this hypothalamus, the long extensions of this ependymal circle get connected. These are also a type of ependymal cells which called as. Okay, they are also an ependymal cells and they are called as tiny cells. Okay, there are totally three varieties of ependymal cells are there. Okay, ependymal cells, choroid epithelial cells and tiny cells. All these are the three varieties of ependymal cells. Microglia, small cells are there. Okay, cells are having small processes, and processes are curly or spiral in nature. Okay, these are the microglia cells. Small cells present in the CNS. They are not actually the origin from the central nervous system. They are not actually the part of nervous tissue. At developmental stage, before birth, some cells, WBC cells from the blood, they escape from and went inside the nervous system and stuck there, and they act as phagocytic cells of CNS, and they protect the CNS by anger. They have the capacity of phagocytosis. They will eat up the debris or the bacteria or inflammation, whatever happens in the CNS, they are going to engulf and reduce them. Okay, so about the Schwann cells, we already know about the myelination. Now we have understood about the neuroglia. In nutshell, the neuroglia are the supportive cells of the CNS. They form major portion of the CNS, 10 times more than the neurons. Okay, 80% is a neuroglia and 20% is a neuron. Together, neuron and neuroglia will form a nervous tissue. Okay, the major component of a mass of a brain is by the neuroglial cells. The divisions we have understood about the classification of the neuroglia as the one is a macroglia and microglia in CNS. In PNS, there are the Schwann cells are there. In CNS, macroglia are three varieties: astrocytes, oligodendrocytes, and ependymal cells. Microglia, astrocytes are again of two varieties, and they are the major component of a CNS. They form the major blood-brain barrier component and help in the nutritional aspect of the CNS. And next is about the oligodendrocytes. They form the myelination around the CNS and protect the CNS by the shock and all. And single new oligodendrocyte can myelinate around the multiple axons, while Schwann cells cannot do that one. So myelination of the CNS is done by the oligodendrocytes, and myelination of the PNS is done by the Schwann cells. Okay, next is about the ependymal cells. Ependymal cells are again of three varieties. One is the ependymal cells, and generally it will present everywhere in the wall of the ventricles. Second one is the choroid epithelial cells, which help present on the choroid plexus of the ventricles and helps in secretion of CSF. And third variety is about the tiny cells. Tiny cells present in the walls of the third and fourth ventricle, and behind their process are going to get connected with the hypothalamus, and they transfer the chemical signals from the ventricle CSF to the hypothalamus directly, and those are called as tiny cells. So this is about the neuroglia cells. We'll meet in the next lecture with some other content.